So can people see my screen?
Yes, looks good.
All right, wonderful. So I'm Stoyan Ivanov. Most of you have probably seen my face as Gaurav has been talking these last 7 helpful weeks. But today I will be leading this talk and intro into macros for use with Fiji. So before we get started, I'm Stoyan Ivanov. I'm part of the core. As you've heard, I specialize in data analysis. The core provides free consultations about data analysis, so you feel free to reach out to me if you've got any questions. We can work on answering them. And if you need any help with microscopes, imaging samples, setting it up and all that, you can contact Gaurav and Laura for that help as well. You've probably seen the map before, the location of our microscopes and the various facilities we have. Please make sure you join our Slack channel. And if you need more news, you can visit our website, ici.emory.edu. Here's the links to the survey form, the Slack channel, and the Google Drive where all of the data is held. You will want to visit it during this talk because there's a few images in there that we'd want to look at together. So go ahead and download that if you haven't already. So what is today's session about? What are you trying to, what are we trying to learn today? Well, I want to introduce you all to the macro language available in Fiji. I want to show you how to use that capability to let you analyze data more quickly and more reliably using these functions. I want to show you how to use the recorder function in Fiji specifically, because that is a very powerful tool that you can go through by hand and it will let you know exactly what kind of functions Fiji is calling and using while it's performing your analysis. So that tool, specifically the recorder tool, provides a lot of insight into how Fiji is doing things, and then it'll make creating macros for analysis much easier. Yeah. And I want to take you just from the start of the development of a macro to kind of an end. It'll be relatively small, but it'll go from concept to execution in this talk. And that's useful. It's like writing a paper. We'll start with the outline and then go till the finished draft. So what is a macro? Well, generally, a macro is a more limited form of programming language, usually attached to an application, in this case, Fiji. It has a lot of utility in that it can make use of the functions and analytical properties of the software that it's attached to, while also being a little more flexible and expansive. For example, you could write a macro that performs the same calculation over an entire stack, an entire set of stacks, an entire folder of data, where normally you might have to do that by hand. So it really allows you to automate a process and to ensure that the calculations you perform are done the same way the entire time for very large data sets. Unlike a proper programming language, it can't do everything another language can. Like, you have a lot more control over say, writing data or reading data with another language like C++ or Python than you do with the Fiji macros. But on the other hand, you don't have access to the same functions that Fiji has access to that you can just call up with the macro. We'll get into more details where we'll define the terms, functions, variables, this, that, and the other, just to make sure that everyone has the same baseline. The links here are to several great web pages that show the built-in macro functions, show what the different operators do, and provide guides on macro development. So normally they're a good resource if you have some questions in the process. If you need to remind yourself on something, do check out those websites. Just check them out. They're very good references. Now, some of you might be asking, why would we want a macro when I can do it by hand? Well, one of the reasons I already mentioned, macros, since they're specified programmatically, they always follow the same set of instructions and they always follow them the same way. Now, if you've got data sets that can, that are pretty well contained, where you capture the data in the same way, and there's not too much variation aside from the signal that you want to see, then they're a very powerful way of being able to analyze that entire stack of data in the same way very quickly. So it allows you to be very rigorous and produce very reproducible analyses, which is one of the big points. Yeah. But how would you start writing a macro? Well, in the same analogy that I had, like writing a paper, it's good to start with an outline. You want to know what you want to do with this macro. What are you looking for? What do you need to calculate exactly? And then you need to specify the steps that you need to take in order to do that. Do you need to do any filtering? Do you need to do any deconvolution? If so, how would you do it? And then only after you've reached the point of how you would do it technically by hand, do you then want to create a macro to do it? Because at that point, you're translating, your understanding of how to analyze this data into the code that the computer will use, or that Fiji, the macro language of Fiji, will use in order to get that same result. And it's generally pretty easy to go from one to the other, but there are instances where it could be troubling. It's also worth keeping in mind who's going to be using this code. Is this something just for your personal library, or do you think you might share it to someone else? And for today's session, it's a more kind of out there concern, but it's still something worth keeping in mind is how much data are you processing? How big are the files that you're going to be opening? And how many of them do you want to work on at the same time? I've run into situations, and I've had users who've run into situations where their personal computers, let's say, don't have enough RAM memory to open very large files, very large stacks of data. And so at that point, you need to consider, well, how can I maybe optimize a macro I'm making, or change the way I'm doing the calculations? Maybe I'll calculate bits independently and then combine the results at the very end, because that's the only way that I can look at it on my system. Again, this won't be a concern today, but it is something that as you go forward in writing macros and developing your understanding of them, that you should keep in mind. So now let me introduce you to Pseudocode. This is kind of like that outline that I was talking about. Basically, it's a way of writing down in plain language the steps you want to take in order to perform your analysis. Sometimes people will, kind of combine their native language and some of the vocabulary of the macro or the programming language that they're interested in when they write their pseudocode. Here, just for today's sake, it's as simple and direct as possible. We have our desired macro name at the start, or at the top rather. Then we indicate this is the start of a macro, and then we go through our steps. We want to import this specific file, nucleus-gray.tiff. We want to threshold it like Gaurav did a few weeks ago to these specific parameters. We want to apply that thresholding. We want to turn it into a mask and then save that mask as a reference. Then we want to run the particle analyzer or run analyze particles on that image, output the statistics, save them, and then clean everything up by closing all the windows that would open. And then we end, and that's the end of the macro. So really what it is, it's a set of instructions you want to repeat, maybe just once, maybe several times in a row, if you're looking at a set of outputs, a set of stacks, or what have you. But this is a good way to visualize it, because even now, we've already taken care of some of the issues that could crop up as we're writing a macro. We've split the process up into its smallest elements, and then we can list them in this way, where each of these elements will correspond in the actual macro to one, at most 2 or 3 lines of code. To write a macro in Fiji, Fiji actually has an environment that's pretty good for that. You would open up your macro window. If you go to Fiji under plugins, new macro will open up that window you see. So actually, oops, let's try and do that now. New macro. All right. These are the 2 examples that I've included with your data. They are for your reference. We'll end up walking our way through this one today, if not both of them. And basically, yeah, this is the environment. This is where you'll type in the commands and where you will run them and debug them. Something to note, if you've never programmed before, all of the lines are numbered. This is actually a very good thing, because if the macro you're running ever stops because it's encountered an error or crashed for some reason or can't proceed for any number of reasons, you'll get the line number of where that error occurred. And that's generally very good if you're doing debugging, because you'll be able to find exactly more or less what call created the error, so you can diagnose it and restore it. And the second thing we want to open is the recorder. So that's under Fiji plugins, macros, record. So Fiji plugins, macros, and record. This is a relatively simple window here, but you will note every time you perform any kind of action with Fiji, you will get a note here on what was called, what function was used. So let me open this guy, nucleus gray, the one we want to open. Image is open, and this is what Fiji did. It it used the open function on the file located here. And this is just a long path to nucleus-gray.tiff. So in fact, let's do this while we're here. If we copy that line and we put it in an empty macro like that, we can say run and it'll open it again. It's that direct. So those are the two tools we'll be using today pretty strongly. Now, there's still a bit more of an introduction. Still a bit more of an introduction to macros and programming. So we'll continue with that. We'll come back as I take you through an entire macro, and we'll in fact play with the recorder just so you can all get a sense of how it works and how it's used and what its limitations are. So to program anything, you need to understand the syntax and the vocabulary of that language. Now, the vocabulary is basically just what are the functions that are built into the macro language. Open, for example, I'd call a vocabulary word because you know it's a function and then you know what it does. It opens a file. The syntax is the way in which keywords like that, function names, variables are arranged in a meaningful way in order to produce a result. So you might have noticed at this point that all the words are, even the numbers are different colors. So that is a pretty common thing in programming where different parts of the language will show up in different colors. And that's chiefly to aid in readability, because if it was all black, it might inhibit your ability to figure out where a function is being used versus a variable versus any other kind of stuff. So for example, you'll note in the example here, all the function calls are kind of orange: select window, run, rename. These are all functions. Strings are kind of pink, and a string is, you know, any kind of collection of characters or symbols that is explicitly not numeric. We'll cover that in the next slide. Variables like a loop name and SB input are written in black. I here is also a variable because it changes. And comments are, for example, green. 2 forward slashes like this comments out the line. And what that means is whatever the macro interface interprets, it won't see that line. It won't react to it. And it's useful to have comments in code just so that 6 months down the road, you can remember what that line did and why it was written that way, hopefully. Let's also cover, while we're here, the parentheses, curly brackets, and quotation marks. So any kind of string, you know, any letter, any file name needs to be identified as a string by surrounding it on either side with quotation marks. Curly brackets, like you can see in this, in line 13 to 23, designate a piece of code as just a subunit of code that is performed together. So everything that happens in between those curly brackets will always happen together. It's not like it can be split up. And that kind of, well, that means if you do anything like a loop where you perform the same analysis on different sets of data, it will always be performed the same way. And parentheses generally separate variables from each other and usually contain the inputs for a function. So you'll see run here is a function with the input of grays. That grays has to come in between those two parentheses so that the function knows what to do. The same way here at the top, the parentheses delineate these calculations and these comparisons inside of them without consideration for the code around them until that calculation is complete. In a way that's similar to in mathematics, if you recall, where putting something in parentheses increases the importance of the, okay, see, if you put it in parentheses, you do it before you do other stuff, under the order of operations. It does something similar in the macro language, where that comparison is done first, and also it specifies input for functions. So now that we've got that overview, what is a variable? In computer science, it's an abstract storage location somewhere on the computer, on the RAM, in the hard drive, paired with an ID so that you can go see where it is. And there are generally two types of variables that we're going to run into, which is strings and numerics. So a string is, as I mentioned, just a collection of symbols that aren't treated as numbers. So hello, comma, world, exclamation point. If it's within those two sets of quotation marks, is a string. And the variable name message refers to that specific string, hello world. If it was numerical, you would write it down like the example right below, total count as the variable name, and right now it's assigned the value of 57. So if you ever call total count later on, if you ever say print it to the screen or do any kind of manipulation to it or mathematical multiplication, if you multiply total count by 5, you are multiplying that value that's assigned to it. Relatively straightforward. Finally, a function is a set of instructions bundled together to perform a certain task or achieve a specific outcome. Fiji has a lot of functions. Some of them take input parameters, some of them don't. Some of them produce outputs, some of them don't. Some of them may open new windows or not. It depends on the function and it depends on what it was trying to achieve. So to go back to the previous example down here, we have the function open, and in parentheses is its input, which is the name of the file we're looking for, nucleusgray.tiff. Right below that, we've got the function setThreshold, which sets the threshold for the image within those two parameters. Now, open takes one input. setThreshold takes two input, a lower limit and an upper limit. And if you ever write your own functions, which you can do, they could take as many or as few inputs as you need to, and they can have or as many or as few outputs as you need. So while we're here, let's take a quick look at the list of all of the macro functions available in Fiji. Now, this is quite a long list, but it contains all of the functions that are built into Fiji. And you can find what you need and then look at the input requirements. You can figure out what you need to do, which ones are useful, and then how to use them. A very good way to navigate this list is Control F. example, the close function here does not take an input. If we were to type this in a macro, whenever we ran this, it will close whatever image is active. So for example, we've got the gray, nucleus gray that we opened, and the macro here. So we've got one active image, which is the nucleus. So if we type close, that would close the window. And in fact, you might have noticed this environment is such that as you're typing in functions, and it's a real function, you'll get this pop-up, which basically just shows you the Fiji interpreter's guess as to what you're trying to do. And it's really helpful if you can almost, but not quite remember the name of a function when you're programming, or if you're just wondering what inputs it takes, because that will help you narrow it down. And we see once we ran the script here, the recorder tells us we ran script macro.imjm, which is in fact right here. So it knows that we ran this script. It doesn't know exactly what the script does, but it does record that it was activated. A few good practices. I already mentioned that anyone who programs really, but especially if you're a beginner in programming, you want to get in the habit of heavily commenting your code, which is basically, as I mentioned, going through the macro or going through your work and making sure that you specify what each line does or what each collection of lines does. For example, the one I wrote, I have myself listed as the author, the date, and the purpose. What does this macro do in general? If I were to send this out to someone, to a colleague at another university or at another school, I might also include my contact information. If anyone was looking at this and had issues with it, they would know how to reach me if they had questions. And then for almost every action taken, I have a comment that describes what it's doing and why it's doing it. And again, it's a good habit to get into. Yeah, it's just a good habit to get into. I know I've come back to code that's been, a few months old, and sometimes I can't make heads or tails of it. So definitely, I wish that I would, definitely those times I wish I had done the commenting ahead of time. A second consideration is to make sure the code is readable. And that basically depends on what you're doing. But in general, if you write a code or a function, and you come back to it, you want to make sure you can tell what's going on. So the example here is that some function, that's not a real function, it's just a placeholder name that takes all of this input. And for the function here, I have explicitly stated the input numerically and whatever strings it needs as input. I've stated them there directly. In the future, if I ever needed to change one of those values, I would have to find where I call this function and then type out the changes to the first, to the second, to the third, etc., to all of the inputs. And if I ever called the function anywhere else, I'd have to go there as well and make the same changes. And that introduces one, the danger that you will make a mistake in typing out the numbers, and two, that you might miss some instances where you've called the function and you may not have updated that data. And the result is you can get errors, or even worse, you won't get any errors, but the results will be questionable because you've missed something in the code, you've missed a change. So it's good to get into the habit of creating descriptive variables and then assigning them the values you want to use as inputs later on. And not only does this make it so that there's only one place now in your macro where you would need to change the value, but also it makes it a little more readable. Variable names that are very short, like A or B or alpha, maybe, they're easy to type, they're short, but they don't really tell you what that variable is holding. So the examples below, like size of region or maximum intensity or title of input, these are useful because just looking at them, you can say, oh, this tells me about what it's doing. And when I go to the function and look at it, I can say, oh, now I know what I'm trying to do. And it generally cuts down on transcription errors or topological errors. If you're ever trying to update it, it's much easier to update those few variables you've defined at the very start. So finally, we're at our example. Here is, we've already seen the pseudocode here. So right now, I will take you through this process using the record utility. And we will see how that goes. Now, before we get started on that, does anyone have any questions? All right. So let's close this. All right.
So, Stoyan, there are different languages that pop up when you want to create your own macro.
Yeah.
Can you briefly go over the different language options that are available to write a macro in? For example, IGM, you can also have Python and so on, and what language you need to stick into for you to read the macro.
Yeah. So the macro language in Fiji is this one here. You can type up, you can program in other languages. You can have Fiji use their syntax or interpret it in a way that it would work with the macros. That's generally a more advanced feature that we won't get into today. But it could allow you to maybe use a library from maybe a Java library or an R library, or make Fiji play nicely with some other programming language, and it could make you, and it could let you do some more advanced things, but it's also a more advanced concept. Does that answer your question?
Yes, that does, John. Thanks.
Okay. So yeah, make sure you're working here. IJ1 macro. All right, so let's see how I want to put this. We've got Fiji, we've got our nucleus, and we've got our recorder. So let's get rid of everything else. We can see the pseudocode here. So first, we want to import nucleus gray.tiff There it is. And we've got the function specified here. Now let's go to just threshold set 6172 265535. Okay. And this is exactly the steps Gaurav outlined in week 3. Okay, we click apply. There we are. Now we want to create a mask, convert to mask. I want to save this as a TIFF. As a reference for me. And analyze particles. We use the default setup. That's bizarre. I have to check add to manager. Yeah. So we see them now. Got the ROI manager and the nuclei identified here. We want to select all of them and measure. That was it. We have the areas. Now we want to save that as a stats.csv. Then we can close all the windows. And what do we have as our results? We've got nuclei stats as a CSV, just like we wanted. Now, what did it do here and how can we turn that into a macro? So let's do this first. Let's open up the macro folders here and try and run that. Aha, but we encounter an error that it cannot write to nuclei-stats.csv because that file is already open. That is something to note. When ImageJ saves a file, it wants to write a new file with the same name. If a file is open, such as this one, which is still open in Excel, it prevents ImageJ from starting that process. So it throws an error and it interrupts the macro. So when you are managing your input/output, keep that in mind. Something else that didn't occur, but I can show you is, let's see. Is if we have the close function here, that will close the active window, which is our image. If you're running a macro in the background, even if it takes a while to run, don't interact with image or Fiji. Don't click on windows, don't move them around because that can interrupt the way the macro is running. Fiji, a big part of the way that Fiji does calculations and analysis is to select different windows it has open. So you've seen before, if you don't have the right window selected, the commands you're trying to enter are going to say, oh, there's no image or no stack, and you get that kind of error, even if you're doing it manually. So if a macro is running, just leave Fiji alone. Don't try and do something else in addition to running the macro in the background, because the potential exists that you will interrupt something it's trying to do. Now, we've got all the commands here, and they produce what we wanted. However, this code not only has some redundancies like lines 7 and 8 here, it also is not very readable. So at this point, once you have a skeleton that works, you would want to go and spend some more time looking through it and then making sure you understand what's happening and then making sure it's being done properly. So as I mentioned, I've included an introduction in the macro. I've commented on all of the actions that we've taken. We opened the gray nucleus.gray.tiff. We set the thresholds, providing the two limits. We call this function run to convert to mask. We specifically select that window again that was changed, and that's just to ensure that nothing odd happens, just in case the focus was on another window Fiji had open. We want to make sure that we're working on the exact window of interest, which is why I explicitly state here, look at this window. We save a copy of the TIFF. We run the analyze particles function. We don't provide any additional inputs, so this is being run under the default settings. We select all of the objects in the ROI manager by running select all. We run the ROI manager function measure, and then we save the results in a CSV. And then at the very end, just to make sure everything is clean, we close all the windows. So let's take a moment with that macro. And that's it. It took us maybe about a minute to run the analysis by hand. It takes just a couple of seconds to run it as a macro. So it's quite an increase in speed. And once you've proofread your code and it works, that's the big if, it's quite a lot less hassle. Oops. So now something a little more complicated. If you want to do an analysis where you're repeating something several times, you might use a loop, or you might use a for loop. And that basically means for some set of data, for X times or for X set of inputs, I will analyze it in the same way with slight changes. And yeah, do we have a question? Yes, actually. Yeah, so before we move on to the for loop, why doesn't everyone try and repeat what I did here with the recorder to see if it works for them? to get the statistics into a .csv file from the nucleus-grade TIFF. So let's take about 10-15 minutes to do that, and let me know if any of you have questions. Right, now we'll get introduced, we'll get familiar with the for loop. Now, what's a for loop? As I started explaining, it is basically a little batch of code that you run over and over again with different inputs or on different data sets. And I've got an example of that as well with your data for today's course. And basically what I have the macro doing is running the calculations for the thresholding like we just did, except several times under different conditions to see what the results look like. And I do the same for a Gaussian filter on that image. And that is useful so that if you're trying to figure out something like what's a good threshold range for this kind of data, or what is a good sigma value for me to apply to my data, instead of running it by hand once and you're like, oh, I need to do it again, or this is too much, or this is too little, you can just program a macro to run it 10, 20 times, show you a range of results, and then you can see, oh, okay, this range or this specific value is good enough for me, or meets the criteria of what I'm studying. So let's try and run this. Oops. Now let's try and run. And we have an error. What is the error? Aha. So this is the very specific path, but I put that in when I was on a different computer. So normally, if you want to unambiguously specify the location of a file to a program, you would include this entire line. If, however, your macro is located in the same folder as this file, like ours is, there's our macro, and then there's the file, you can just type in the name of the file. That does make it tricky if you're moving from system to system, or if your file structure changes, but you know, it's something you're doing the first time. It's all right to do.
So Stoyan, if I want
Yes.
to end up getting a dialog box over there which says, as soon as you hit, if you run the code, if I want to specify open, the dialog box comes out and tells me open a particular folder, right? How do I do that? Because I think that will be much more easier, so that it doesn't matter where your macro is, you can tell where the file location is.
Yeah. So if you run open without any input arguments, it will open up the interface and allow you to select. This does make it a bit more interactive. So if you're doing if you're processing large amounts of data, you wouldn't want to do this. But as Gaurav mentioned, it is useful in cases like this.
That's very helpful. Thanks, John.
Yeah, you open that here, click open. There it is, and then it goes on. Okay, so we've encountered an error in line 11. It's a bit tricky, but this requires a stack, 16-bit in line 11. So this here at the end tells you where the error is. Line 11. So line 11 is run stack to images. And what that command there is doing is taking a stack of images and removing them from the stack, essentially opening 3 different. And actually, it makes sense that that came up because I specified the wrong file. I did not want to open nucleus gray. I wanted to open this one, crop composite. So if I click on that, so let me open, yeah. What the run stack to images is basically breaking this down into its 3 components. And from there, we then move into the for loop, which applies the thresholds to this data with several different parameters. With this code. So the error that we saw was, again, a path error here, where I'm specifying unambiguously the folder you're saving it in. That was also on a different computer. So, and if you'll note, this kind of problem is exactly the problem one hopes to avoid by specifying the path in a variable at the very start of a macro. If I had done that, for example, I wouldn't have to go to the save as function here or the open function here and then change that input. I could just change the variable. But since we're here already, let's grade that tip. And here, background subtraction. Okay, so that's changed, that's changed. Let's make sure we close all of our windows. Control S. We don't want to lose anything when we're making changes. Let's run. So crop composite. And here, now the result is, let's see. Yeah. Yeah. We pull those up and we will go through the process. Yeah. this for loop initially looks or performs the same thresholding operation with different inputs. And we can see in the stack that it output here what that looks like. The input variable is specified here at the top. And we can see how the thresholding performs within a certain range. And then we can choose from these what the best result is. Now, how do we start a for loop? We first have to call the loop for, and then in parentheses, we have this set here. And that indicates the initial index, the end index, and the size increment. And that basically means from 1 to 51, I will do a calculation and then jump 5 units. Now, this is just a way for the macro language to keep track of how many times it needs to repeat this piece of code. But as it's doing that, we can use the index here as it's changing to modify the inputs. So for example, I'm running the subtract background function in Fiji, and I'm coming up with the input for how aggressively or what the radius of the rolling ball background removal is. And as the index is increasing, 1 to 6 to 11, the function is also changing its input. And I get a stack of output that looks like this. For every instance I've calculated it, I get that different output. Now, does that make sense to people? Does anyone have questions on this part? Okay.
So this is super cool. I do have a question on this.
Yeah, go on.
When you use the, I kind of got the point that I equals to 1, that's where you want to start from. I equals to 51, that's how far you want to go. And you want to go at the increments of 5. So that's going to give you 10 frames or 10 integers.
That's right.
But at the bottom, line number 20, when you have a rolling of plus I, is that the rolling ball subtraction radius we are selecting, going from 1 through 5 through 10?
That is an excellent question. Thank you for asking it. If you all look at line 16 and line 20, as Gaurav mentioned. Now, what I'm doing there is something called concatenation. I have a name or a string that I want to use. And line 16, it's crop-composite-0003 dash some other number. I get that number using the index value, but that's an integer. So by writing this command in line 16 and then again in line 20, you're essentially appending the integer I into the rest of the string. So crop composite 0003 is 1 at I equals 1 and is 6 at I equals 6. And in fact, you can see that here, where at the top, we have the name of each of the slices of the stack. And this is where we've appended 1. This is where we've appended 6. This is where we've appended 11. What that's doing in line 21 or 20 then is modifying the string that will be the input argument for the function we're running in line 21. that was a little complicated, but does that make sense, Gaurav?
Yeah, it does make sense. So loop name is a new variable that you are using, and for different functions, you are invoking that variable for further image calculations. Is that correct?
Exactly.
Okay.
So in fact, yeah, what I'm doing here in line 14 is I'm explicitly capturing, let me just, let's go through it, in fact. Crop composite, yeah. So before this loop, what I've done is I've taken the stack and I've decomposed it into images, single images. We're interested in this guy, whose
Right.
name is crop composite 0003. That's the one we want to analyze. So the first line of the loop is to make sure that window is our focus. We then run grays, which turns it into grayscale. And then this is where we're kind of doing a sleight of hand. We are generating a new name for this image. And that name is going to be crop composite 0003 plus the iteration of the for loop at which we're doing the modification. That name is then held in the loop name variable. Then we run duplicate. So image duplicate. That produces this guy. Same name, but with a -1 at the end. However, when that's duplicated, that is the window which is selected by Fiji. That's the window in the very front. So when we have that, we say rename to the loop name. So we rename this duplicate into our new image name that we want to keep. Once we do that, we make sure just for posterity to select that window again. So it's this one. And then at that point, we specify the input for the function, and then we run that function. So here, subtract background. Radius is in pixels. So at I1, it would be, yeah, 1.
1.
And we click and we get that. Now, this image then isn't closed. It stays open. But the loop goes back and selects this one again and repeats the process. And once it's repeated the entire process, we can then take all these disparate images, put them into a stack, and then save that stack and open it up later if we want to see how the removal of the background went. Which of these values is pretty good for our data.
So how did all the images which were opened got into one stack? Is there a command you used for that?
There is. So this is the open command. This is the stack to images one that I ran. We go through this 10 times,
Okay.
and then we start closing. We close the first 3 that we'd opened. So those are gone. At that point, every image left is one that we have processed. So here in line 28, we run images to stack, which gets all of the images that are currently opened in Fiji and puts them into a stack and orders them by name, I believe, is the default way to order them. So it goes 1, 6, 9, because that's how the names differ. Then we save that all as a TIFF, and anything that's open at the end, we close so that it's just the Fiji interface at the very end.
No, I find this really cool because this can help you compare different background subtraction or correction schemes within the image and a lot more. So yeah,
Exactly.
it's really cool. Thanks, Darren.
And what I had said before was, don't touch anything while it's working. This section here, once it duplicates the image, it assumes that that new duplicate is at the top, so it interacts with it. It doesn't call it out explicitly, which means if I had clicked somewhere else or opened up another image while this macro was running, I would have interrupted the process and maybe caused it to crash, which is why it's important not to let that happen. Depending on how well developed and written a macro is, if say you're using someone else's, this may all be done in the background. But here, as a first intro to the process, we're doing it, very explicitly, kind of messily, but hopefully that helps you learn. Right. The second stack basically does the same thing, except instead of the background subtraction function, we're running the Gaussian blur function. And that's done in a similar way. We open the file of interest, we select the window, the name of which we know, we specify a new name for each of the images we produce. And at the very end, we close all the ones we don't need, we put them in the stack and we export that. And what that looks like is, I already saw it, is here. So from start to finish, see them getting blurrier. And we have ng-0.1, which is how large the sigma is. Yeah. The scaled sigma, I should say. So at this point, when am I starting to lose my boundary? Well, looks like it's around sigma 0.4. After that, it becomes very diffuse. But that's the kind of thing you can do with a macro. I know I've tried to do this by hand previously, and it's relatively tedious and difficult to process a single image and then save it, and then process a different one and then save it, so that I could have a bunch of ones to compare the results with. So definitely, I think this is easier and much more versatile. So does anyone have questions about how we got here? Okay.
Just to make sure that I understood it in the right way. So is it something like we are programming it in a way that it automatically duplicate the image and then apply the threshold of whatever we ask it to, like 5 or 10, and then on that duplicate image, and then again duplicate it and then apply threshold of say 10 this time, and then again duplicate it and apply threshold of increment say 15 this time, and then at the end combine all the images together?
Yeah, exactly. So
and then so that we can just compare like which threshold is working best for our image.
Exactly.
Okay.
Yeah.
That's nice. Okay.
And this is just the tip of the iceberg, as they say. This is one way to apply it. There's any other kind of function that you might want to run repeatedly to see how it looks. You can do this way, and the more skill you build up generating macros for Fiji, you can move on to a lot more complex things. Image analysis together, subtraction, addition, denoising. And if you've got I've mentioned several times, but it's really important to remember, if you've got a lot of data and you analyze it in a similar way, this, if you can get it working, will be fantastic. So why doesn't everyone take maybe 10 minutes to look through the looped thresholds macro? See if you can get it running on your machine. And if you've got any trouble, go ahead and ask. Go ahead and ask me if you have any questions on how to get that running. All right, so if anyone still has questions, feel free to ask. But before we conclude for today, I wanted to go over one last part. You might have noticed the way that some of the, where are we? There you are. How some of the components here are compared. We've got equals, greater than, or less than, and then I plus equals 5, which means 5 is added to I, and then that's the new I. Those are operators. And we've got, in fact, a list of operators linked here on slide 19. And they will allow you to do some of the more complex comparisons that might be used in if statements, if else statements, if you end up needing that, or in other kinds of loops. So the top here, plus plus and minus minus, that's shorthand for I want this variable incremented by 1 or decremented by 1. That's one of the ones that you'll see used more often, usually in instances where you're inside a while loop, for example, or a for loop where you want to keep a running counter of how many iterations you've had in cases where your index is maybe not this linear. Let's say. But yeah, these operators, pretty good to know. They're pretty good reference. Right. So that, I think, concludes the talk for today. I know we got started a little late, but we're getting done a little early. If anyone has questions now or later, feel free to reach out to me. We can go over your questions. I can consult with you if you're interested in writing your own macro for any purpose, any specific purpose. Otherwise, that's it for today. Next week, we will have a little demonstration of using MRS and Vision 4D. I believe that's what's on the schedule, just to look at some three-dimensional data and see some of the strengths and weaknesses, or just some of the strengths of those softwares in terms of analysis and visualization. So that will also be exciting.
Thanks, Dan.
Thank you all.